let's start our next unit in Math 20-1, which is rational expressions. This unit has 4 lessons, and I will be doing the first lesson with you, which is on simplifying rational expressions. So before I'm going to talk about rational expressions, I would like to talk a little bit about rational numbers that you have learned in your previous grades. So rational numbers can be expressed as a fraction of 2 integers. So I'm going to write a general form for rational numbers. So rational numbers can be written as the fraction of p and q, where p and q belongs to integers and q is not equal to 0. So let's see a few examples that represent this expression. So 3 by 4 is a rational number because 3 and 4, they both are integers and our denominator is not equal to 0 here. Let's take another example, negative 5 by 8. So negative 5 and 8, they both are integers and our denominator is not equal to 0. So let's look at rational expressions now. Rational expressions are an algebraically fraction with the numerator and denominator that are both polynomials. Let's look at a few examples of rational expressions. So 1 by x is a rational expression because our numerator and denominator, they both are polynomials here. Same thing, x divided by x plus 1 is a rational expression because it's a quotient of 2 polynomials. So x squared minus 1 divided by x squared plus 2x plus 1 is also a rational expression. X squared minus 4 is a rational expression because I can write this over 1. Remember one thing, that the process of simplifying rational expressions is very much similar to the process of simplifying rational numbers that you have learned in your previous grades. So let's look at the example. In this example, you have to identify the rational expressions and justify your answer. So the first one is square root of x divided by 3. So square root of x divided by 3 is not a rational expression because square root of x is not a polynomial. So in particular, for an expression to be a polynomial term, it must contain no square roots of variables, no fractional or negative powers on the variables. So therefore, a numerator here is square root of x, that is not a polynomial. So square root of x divided by 3 is not a rational expression. So 3x squared plus 5x minus 16 is not a rational expression. Is a rational expression because I can write this over 1. Next, x squared minus 16 divided by x plus 4 is also a rational expression. Now we're going to talk about non-permissible values. Before I'm going to talk about non-permissible values, I will solve this expression by plugging different values of x. So let's complete this table. So when you plug x equal to -1 in this expression, your answer will be -1. When you plug x equal to 0, your answer will be 1. And when you plug x equal to 1 here, your denominator will be 0, so then your expression is undefined. So for this expression, my answer will be undefined. And when I plug x equal to 2, my answer will be 11. And for x equal to 3, the answer is 13. Okay, what is happening to the expression when x equal to 1? So the expression is undefined because we cannot divide anything by 0. Okay, so non-permissible values, also called NPVs, is any value for a variable that results in the expression being undefined. So in the case for rational expressions, the NPVs are the values that result in denominator equal to 0. So let's do a few examples where we have to determine the non-permissible values for the rational expressions. So determine the non-permissible values for the following rational expressions. The first question is 3x divided by 4 minus x. So this is a rational expression and we have to find the non-permissible value. To calculate the non-permissible value, we're going to set our denominator equal to 0. And we'll solve for x. So I'm going to add x both sides. So my x is equal to 4 or 4 equal to x is the same thing. So when I plug my value of x equal to 4 in this expression, my denominator will be 0. So I would say my non-permissible value for this expression is x should not be equal to 4. I can also say that my restriction for this expression is x should not be equal to 4. So let's do next question, question number 2. So I have two expressions in my denominator. I'm gonna set them equal to 0. So here I have the product of these two expressions equal to 0. It means that either a minus 4 is equal to 0 or a plus 2 is equal to 0. So let's simplify for a. So from here, I'll get a equal to 4 and a equal to negative 2. So my non-permissible values for this expression are a should not be equal to 4 and should not be equal to negative 2. Because when I plug the value of a as 4, so 4 minus 4 is 0. And in my denominator, when I multiply 0 with anything, will be 0. So my expression will not be defined. In the same way, when I plug x equal to negative 2, my denominator will be 0. So next question, 2k plus 8 divided by k square. In order to calculate non-permissible value, I'm gonna set my denominator equal to 0. K square equal to 0 means k equal to 0. So non-permissible value for this expression is k should not be equal to 0. Okay. Let's do next two examples here. Determine the non-permissible values for the following rational expressions. So first is 3x minus 6 divided by 2x squared plus x minus 10. In order to determine your non-permissible value, you're going to plug your denominator equal to 0. I'm going to set this denominator equal to 0. And now we're going to factor this denominator. So the factors of this quadratic equation are 2x plus 5 and x minus 2. So from here, we'll get 2x plus 5 equal to 0 or x minus 2 equal to 0. And we'll simplify for x. So my non-permissible values for this expression are x cannot be equal to 2 and negative 5 by 2, because when I plug x as 2, my denominator will be 0, and when I plug x as negative 5 by 2, my denominator will again be 0. Okay, so this expression is not defined at x equal to 2 or x equal to negative 5 by 2. Let's do question number 2. We have 1 minus t divided by t squared minus 1. Let's set our denominator equal to 0. This is difference of squares. T squared minus 1 square can be written as t minus 1 and t plus 1 equal to 0. So from here, either t minus 1 equal to 0 or t plus 1 equal to 0. So t is equal to 1 or t equal to negative 1. Okay, so my non-permissible values for this expression are t should not be equal to 1 and it should not be equal to negative 1. Okay, because my denominator will be 0. Okay, next. Steps to simplify rational expressions. So there are 4 steps that you need to keep in mind when you're simplifying rational expressions. The first one is factor everything. Second is clearly state all non-permissible values before proceeding to simplify. And third is divide out any common factors. The last one, leave your answer in factored form. Okay, let's simplify this expression. So this expression is 3x minus 6 divided by 2x squared plus x minus 10. So first thing is factor everything. So both in numerator and denominator factor this expression. So 3 is the greatest common factor in the numerator. So my numerator is 3 times x minus 2 and my denominator is a quadratic equation. And when I factor this quadratic equation, I will get 2x plus 5 and x minus 2. Okay, so we have factored everything. So this is our first step. Second step is simplify, clearly state all the non-permissible values. So let's look for non-permissible values here. So non-permissible values will be x should not be equal to -5/2 and x should not be equal to 2, because when I plug x as -5/2 or 2, my denominator will be 0. Step 3 is divide out any common factors. So our common factors are x minus 2. So I'm left with 3 divided by 2x plus 5. Remember one thing, whenever you're looking for non-permissible values, you're always looking at your original equation. So you're not looking at your simplified answer, okay? Because if you see here, your non-permissible value will be only x not equal to -5/2, right? But if you look here, before you cancel out these common factors, your non-permissible values are -5/2 and 2. So always find the non-permissible values before you're going to cancel out the common factors. Okay, let's do question number 2. So in the numerator, we have 1 minus t. In the denominator, we have difference of squares. We can write t squared minus 1 as t minus 1, t plus 1. So let's calculate our non-permissible values first. So non-permissible values are t should not be equal to 1 or -1. Now let's simplify by canceling out the common factors. So in the numerator, I can take negative out, and I can write that 1 minus t as -1 plus t, because it's the same thing. When I open the bracket, I will get +1 and -t. Okay. -1 plus t can also be written as t minus 1. T minus 1 and t minus 1 will cancel out because they both are common factors here. So my answer is -1 divided by t plus 1. Okay, let's do these two examples. So x squared minus 9x plus 20 divided by x squared plus 10x plus 25. So you have a quadratic equation in the numerator and also a quadratic equation in the denominator. So I'm going to factor out these two quadratic equations. So in the numerator, when I factor this quadratic equation, I'll get x plus 4 and x plus 5. And in the denominator, I'll get x plus 5 and x plus 5. Okay, before I'm going to cancel out the common factors, I'm going to calculate my non-permissible values. Okay, so non-permissible values are, there's only one. X should not be equal to -5. Okay, now I'm going to cancel out the common factors. So my answer is x plus 4 divided by x plus 5. Okay, let's do this last question here. X minus 4 divided by 4 minus x. So let's factor out our numerator by taking negative out, and I'm left with the -x plus 4 in the numerator divided by 4 minus x. So this can also be written as -x plus 4 can also be written as 4 minus x divided by 4 minus x. Okay, now I'm going to calculate my non-permissible value. Non-permissible value here is x should not be equal to 4. And now let's simplify this by canceling out the common factors. So our answer is -1. Okay, that's it for this lesson. Thank you.